Hello everyone, welcome back to our LeetCode discussion. Today we're going to look at problem 1143, which is longest common subsequence. Given two strings, text1 and text2, return the length of their longest common subsequence. If there is no common subsequence, return 0. A subsequence of a string is a new string generated from the original string with some characters. It can be non-deleted without changing the relative order of the remaining characters. For example, ACE is a subsequence of A, B, C, D, E. A common subsequence of two strings is a subsequence that is common to both strings. Alright, so let's look at example 1 there. We have A, B, C, D, E, and A, C, E. So we see that we have ACE here, so the longest common subsequence is ACE. Yep, correct. Second example, we have ABC and also ABC. Then we can see that the longest common subsequence is also ABC. Example 3, ABC and DEF. So there's no common thing here. The length should be 0. Correct. And I believe I understand the problem now. And we have to just clarify a few things. One is, what is the length of text1 and text2? So it's given by between 1 to 1000. Yeah, I think that's all we need for now. So longest common subsequence. I think one obvious thing when I work on the example 1 there is that we try to match as many as possible as we move along. So when we see A, B, C, D, E, and then we look through the second one, we have A, C, E. So when we first both see A and A, then we match them. Move on, we have B. B is not in there. So, but we expect C. And then next time we see C, we match it. And then next time we see E, so we match it again. But how do we know that how do we know when we need to skip a particular character? So what I mean is that I'm gonna put in example 4 here. So we have A, B, C, D, E, and then we have A, B, C, and E. No, sorry, we have A, T, C, E. No, how about A, F, C, E? So I think we need to consider two things. We could skip a character or we take it. But how do we do it efficiently? I think that's the question. Because we don't want to explore all the possible solutions. So how about if we take everything and then we cannot do that, then we try to skip one, and so on and so on. So let's say we have A, B, C, D, E, and then we try to match with A, F, C, E. So let's see. When we have A, B, C, D, E, and then we try to match with A, F, C, E, then we see that we have matched one of them, so which is A, then we are left with B, C, D, E, and F, C, E. So what is the longest common subsequence of B, C, D, E, and F, C, E? Okay, I think I got some idea here. So how about, I think we can write down this problem as f of A, B, C, D, E, and A, F, C, E is 1 plus f of B, C, D, E, and F, C, E. So what is the f of B, C, D, E, and F, C, E? So I think there are two possible ways. So we see that first character doesn't match. What we can do, I think we can use an indicator here, whether the first one is match, the first character match, plus, I think what we can do is we take the max of f of CDE and FCE, or we could take f of BCDE and CE. Right. And we see that this answer is 0 plus 2. So the final answer is 3. Alright, but does it sound reasonable to you? Yeah, I think this sounds reasonable. But how do we turn this idea into efficient code? So I think we can use a recursive method here. As I said, we could use the f there. So let's say we have the f of t1 and t2. So we have t1, t2. What we can do is use an indicator of t1 0 equals to t2 0 plus the max of f of t2, we move it by 1, and t1 and t2, we take all of them, or it could also be t1, but the t2, we take it from the second towards the end. Right. And I think there should be some overlap when we calculate the maximum there. So during the recursive method, we may have recalculate a function multiple times. So um, what we're gonna do here is that we try to store. How about we try to store it in a dictionary? Yeah, I think that makes sense. Or because the dictionary key would be, I think, the m times n element at most. So how about we just use to turn this problem into a 2D dynamic programming problem. So how we are gonna do that? Okay, so I think we can turn this into a table. So let's say we have A, B. Oh, sorry. So we have A, L, C, E. And then the vertical side, we have A, B, C, D, E. So A will match. And then this would all be 0. Then B, we don't match anything there. C, we can match it in this there, C there. And then D, actually this one. So if we just take the first character of text 1, then we have LCS of 1. Yep. If we take AB, it's still the same. This is all just 1. And then we have a C there, so still 1. And then C, we see a match. So 2. ABC and AFCE have a maximum length of LCS2. So where does this 2 come from? I think we could do it in a diagonal manner. And then we plus 1. Or we could take the maximum there. And then D, this would be 1, 1, 2, 2, then 1, 1, 2, 3. Okay, so here is the recurrence that I found. We have x, y equals to max of I think there are two possible things here. If it match, what happens if it match? Then it basically extended. Okay, so there are two possible things. 1 plus f of x minus 1, y minus 1, if match. Otherwise, if it doesn't match, then we take the maximum of f of x minus 1, comma y, or it could be fx, comma y minus 1. Otherwise, let me just write else there. Yep. Does this sound reasonable to you? Yeah, I think it's reasonable. Let me try to work it out on the other examples there. So we have example 1. We have A, B, C. Sorry. A, C, E. Then A, B, C, D, E. A, it match. I think it's good to have a buffer. So what I mean by buffer is that, actually let me rewrite this. So we have x, A, C, E. Then we have x, A, B, C, D, E. So initially it's all 0. Then first column is all 0, 2. Then we have A here, match, so plus 1, 1, 1. B doesn't match. C, we see that it matches there. So 1 to 2. And then D, still 1 to 2. And then E, we see it match. So the answer is 3. Correct. Example 2, we have X, A, B, C, then X, A, B, C. So how are we gonna build this? You're gonna do this is 1, 1, 1. This is 1, 2, 2, 0, 1, 2, 3. Sample 3 we have X, A, B, C, X, D, E, F. This is 0, 0. Okay, this is all 0. Alright. I would like to move on to programming unless there is a further optimization that you would like me to explore. So, alright. So, here I'm gonna use two arrays here because otherwise it's because I need to keep track of the previous value diagonally. So I need to have the previous row in hand. Now let me write down the prep there. Initialize to all 0 times length of, say, text1 and then curve will be the same. We'll have length of text1. Okay. Now it is time to look through all the characters in the second text. So for C in text 2, I'm gonna do another loop. For I in range from 1 to the length of text1. If C equals text1 of I, then you're gonna increase it in the curve. So curve of I equals the prime of I minus 1 plus 1. Else, the curve of I, no, this would be the max of prime I minus 1, or it could be the current of I minus 1. So on and so forth, in the end, we return the curve. Actually, it's not done yet. At the end of each loop, we need to swap the value. So for in the end, if else prep equals curve, and then once we finish, we return the prep of minus 1. Okay, let me quickly walk through the code again to make sure I don't miss anything. And we have the previous array to start the previous row of the dynamic programming that I just described. And then curve would be the current one that I will override. Then I'm gonna loop through the character in the text 2, and then another loop through all the text in the other text 1. If the character match, I will use the previous of I minus 1, so that will be the diagonal value plus 1. Otherwise, I will just take the maximum of the previous one. So actually the previous is not I minus 1, it's actually I. Because you don't want the diagonal one, you just want the direct upper value. In the end, once this is done, you're gonna swap the value between the prep and the current, so that in the next loop, because in the next loop, the current row would be the previous one. So on and so forth. In the end, we just return the previous, the last column in the previous. So I think that would be it. One thing that I skip here is that we need to swap. This is just a minor optimization. So if text2, if the length of text2 is less than length of text1, then we basically swap it. Text1, text2 equals text2, text1. And then another thing is that we need to append actually we don't need to append it, right? Do we need to append it? I think it's better that we did, otherwise it complicates everything. Okay, let's just do it. Text1 equals space plus text1. Alright, let me test the code to make sure it works as expected. We will have let's look at example 1. We have the prep initialized to all 0. Then we look at A. We see A match. So we get the previous one diagonally, which is 0, plus 1, which is 1. And then we move along. Then we see there is a C there. Again, diagonally is 1. We plus 1 to it. We add 1 to it. We got 2. And then when we see E, we got 3. Yeah, I think this should work. Let me write down the code to make sure it works as expected. If length of text2 is less than length of text1, then we swap it. Text1, text2 equals text2, text1. Then text1 equals space plus text1. Now it's time to look through all the text2 or C in text2, I in range. use enumerate text 1 starting from 1, then call it C2 and C1. So if C1 equals C2, then curl I equals, okay, I forgot to initialize the curl and prep. So prep equals 0 times the length of text 1, and then same for the curl. Yep. Curl equals prep of I minus 1 plus 1. I'm thinking of if there is a better way to implement this so that I don't need to start the I from basically 1. How about we manipulate it later on? Can we do that? Okay, so got an idea. So instead of changing the text, I will change it in the loop itself. Range, range of 1 to length of text plus 1. So if C2 equals to text 1 of I minus 1, then yep, I think that could work. Curl I equals prep I minus 1 plus 1, else current I equals the maximum of curl minus 1, or it could be the prep of I. After the loop, I'm gonna switch prep equals curl. Then I will return the last element of prep. Yep. We think that's out of range. How is that possible? Okay, I got the plus 1. Let me just store it. Length L equals this plus 1 times L times L. Yep, you got it correct. Let me try to submit it. Wrong answer. Expected output is 2, output is 2, expected is 1. So what went wrong here? Okay, let me try to print out the values there. So print prep. Zero zero zero. Let me check the character. J and M, and how come the character is of M? That's a bit weird. Test 1 of I minus 1. Okay, yeah, that makes sense. The I is static. So G, B S B I I B I N I N N. So J M, the M match at the last one, and then K, and then B. So B match there. So B match the second time there is not allowed. But why is it 2? It matched the first B, and then it matched the second B again, but why does it become 2? It can't increase twice because, okay, so it's using the prep, but I'm not updating the prep there. So B matched the first one. Okay, let me try to print out everything instead. It's hard to tell, but we could debug it. So we see here, we have BB when it match. Okay, let me print out the I and J also. No, it's not it. So when we got the B will match, and then second B, hold on. Okay, so I think it's because of my Python understanding here. Um, hmm, yeah, so when I do prep equals curly, they are both pointing to the same array. So how do we solve this? I think we just swapped it, right? Curl into curl, right? Yep. So let's try this out. Got it. Yeah. I think we are pretty efficient. OM times N. I think we are in the majority. So I think we are good, but then I'm wondering how they got it quite efficient there at 10 ms. So let's look at that. Hmm. This one is 2.2. So how is that more efficient than mine? It's impossible. Let me check real quick. What are the suggested complexity for this problem? Yes, n times n. That is the fastest we could do. I think we are good here. Um, let's look at some solution there. So ONN. How do we solve this by most words? Okay, so O of n times n. Yeah. So that is the fastest that we could do. Time ONN. Yep. I think we are good here. So guess we will stop here. Thank you everyone.